Hello everyone, I'm Akash Gupta and you're watching my YouTube channel Nia Labs. So today I'm going to talk about number of significant digit in pi. So if we write pi approximately equal to 3.14, my number of significant digit is 3. But wait, pi is an irrational number. That means it is non-terminating and non-repeating number. So I can write it up to any number of decimal places. So you may conclude the number of significant digit is infinite. So the answer is absolutely correct. The number of significant digit is infinite, which is being asked in almost like many of the competitive examination. But what does this infinite significant term means? Okay, so before I go further, we need to understand the exact meaning of significant digits. So apart from the number of definitions given in textbooks, let's consider one more definition. The number of significant digit is the number of digits which signifies the measuring capacity of a device. Okay, so more number of significant digits in the reading learned from a particular device, that means the reading is more precise, the instrument is more powerful. Okay, let's consider two scales. First scale, which has calibration like 0, 10, 20, 30. Okay, and there is no marking in between 10, 20 or 30. Okay, so one of the student take this particular scale and read the reading as 30. Okay, whatever unit you may choose, like say 30 centimeter. Okay, let's consider one more scale which has marking in between 10, 20, 30 as well. Okay, so let's say there are 10 divisions in between them, and second student comes, let's say Vikas comes and take one more reading and say it is also 30 centimeters. So you have two readings measured from two different scales, 30 centimeter and 30 centimeters. Okay, so what will be the number of significant digit in both the readings? Okay, in both the readings, 30 centimeter from the first scale which has no marking in between 10, 20 and 30, and 30 centimeter from the second scale which has marking in between 10, 20 and 30. Okay, so let's consider. So the traditional rule is that we do not consider trailing zeros in number of significant digit. But this is just a rule. We are going to break it because significant digit depends upon the measuring capacity of a device. We have to consider it. Okay, so if I consider reading of the first scale, which is 30 centimeter, it has just one significant digit because this particular device cannot measure two digits. Okay, between 10 it just measures 20. If you say 21, it is not marked at that device. Okay, more or less it's like 1, 2, 3 cross 10. Okay, but if you consider the reading of the second device, which is 30 centimeter, it can measure 21, 31, 32. So it has significance of the second digit. It does have significance of the second zero. So I will say the number of significant digit in the second reading is 2. So more number of significant digits, that means more accurate, more precise is your result. Okay, more powerful is the device that from which you are measuring your reading. Okay, so let's say if I want to measure area of a circle, okay, area of a circle or the cross section of a sphere. So the area of circle is pi r square, simply pi r square. So you can measure the r from Werner caliper or your geometry scale or some more powerful device, let's say screw gauge, which gives more precise result. Okay, so there will be certain number of significant digit. But did you measure the value of pi from any of the device? No, we didn't measure the value of pi. We will be putting directly the value of pi, whatever our convenience allows us, whether it's 3.14, whether it's 22/7 approximately equal to. Okay, so but we are not going to measure the value of pi from any of the device available to us. We will be putting the value of pi directly. So that means pi is error-free constant that you are using in your calculation. So I can I can draw a relationship between number of significant digit and error in your result. Okay, so more number of significant digit, that means more precise is the result and lesser will be the error. But surprisingly, we are not measuring the value of pi from any of the device. So it is error free. So you can say you have zero error, absolutely zero error in the value of pi. That means number of significant digit will be infinite. You can relate to that. So number of significant digit is infinite. That means the constant, that particular number is constant, error-free constant you are using in your formula to calculate something. For example, if you consider perimeter of a triangle, that is twice of length into breadth. Let's say length is A and breadth is B. So this is twice of A plus B. The parameter is twice of A plus B. So you can measure A and B. So certainly they will have certain error. So we will associate certain number of significant digit. Okay, if you measure the length from the metric scale, that is, let's say, the 6.1 centimeter, that is 2 significant digit, and 4.2 centimeter is the width, that again is 2 significant digit. But 2 twice of A plus B, that 2 that you are using directly in the formula, how many number of significant digit it has? It has infinite number of significant digit. Infinite number of significant digit means that you are not measuring it from any of the device available to you. You are using it directly in your calculation. So whenever you come across number of significant digit is infinite, as such in pi, 2 or any constant you are using in your calculation, that means that it is error free, that you are not measuring it from any of the device. That's why we are saying that number of significant digit is infinite. Okay, so thank you very much for watching this video. Please subscribe.